Hey guys, welcome to Rock the JVM's Java tutorial for beginners. Here you will learn the basics of the Java programming language in just a couple of hours. Now you might be wondering why this video looks a little vertical and weird. That's actually intentional. I made this for you and I'll explain shortly, but first let me introduce myself. My name is Daniel and I founded Rock the JVM. I'm a software engineer and teacher. I've been writing code for more than 10 years now and I've instructed for more than 7 years. I've taught more than 35,000 engineers at this point, and my best students are successful engineers at some of the best companies in the world. I've also held live trainings and instructed teams at some of the best companies out there, including Adobe and Apple. Now, I write code primarily in the Scala programming language, which is more advanced than Java, but I'm also an Oracle certified Java programmer and use and teach technologies based on the Java Virtual Machine, or JVM, which is why my training materials are called Rock the JVM. Now, you can find me at the main rockthejvm.com website, and you can write to me anytime at daniel@rockthejvm.com if you need any advice, or if you want me to create tutorials or courses, or you need me to train your team in your company. So what's up with Java? Now, Java is one of, if not the, most popular programming language in existence. Every single major company uses it in some capacity, and it runs almost any device you can think of, from laptops to smartphones to tablets and watches and a million other devices. Now, why is Java special? For the longest time, programmers had a very hard time creating software because everything that you wrote was suitable for a single processor type and a certain operating system. That's the reason why programs written for Windows don't work for Mac or smartphones unless they have a dedicated separate version. Now, in Java, you don't need to do that. Now, in Java, you write code in a text file, which a compiler turns into a special binary format called bytecode. And that bytecode can then run on any device that supports a Java Virtual Machine, or a JVM. And almost every device supports a JVM because people at various companies, including Oracle and Google, already implemented JVMs for Mac, Windows, and a million other kinds of devices, including Android phones and so on and so forth. Now, in this tutorial, you will learn the basics of programming in Java. So you will learn about variables and types, you will learn control flow statements, you will learn about classes and objects and methods, and you will learn to package your application so that other people can use it. And by the end of this video, you will learn how to write a small chatbot with which you will interact in the console. The small chatbot will guess your age based on some information that you supply it, and the small chatbot will process some information very, very fast. And you will write all of this from scratch, and you don't need any programming experience whatsoever. Now, I promised I would explain why I made this video vertical. Now, I've intentionally made it exactly half of a standard widescreen laptop screen because I want you to code with me. So I will quickly teach you how to install and run a Java development environment, and after you install it, my recommendation is to keep this video on one side of the screen and your own dev environment on the other side. I've personally watched a lot of tech videos in the past, and I personally was very frustrated that I needed to go back and forth between the video and my own code, and I would lose track of what the other person from the video was saying. So I don't want you to do that. I've made this arrangement so that you can see both what I'm doing on the screen and what you're doing at the same time, and you don't fall behind on what I'm saying. If you do happen to fall behind, just pause the video and resume when you are ready. So if you like or hate this arrangement, let me know in the comments. If you like it, I'm going to be making more tutorials in this style. Now, this video is also downloadable at Rock the JVM, and you will also find the cheat sheets from this tutorial. Alright, now that being said, let's install the necessary software tools so that we can write Java code on our computer. The first thing that you will need to install is a Java development kit, which you can find from the Oracle homepage. So open a browser tab and hit JDK download, and go to the Oracle homepage by clicking the first link, and you will install Java SE, which stands for Java Standard Edition. So you will hit JDK download for the latest Java Standard Edition 14 at the moment of this recording, but whatever Java version you download is fine. And then you will need to scroll down and download the JDK for your particular platform. I'm on a Mac, and so I will install the DMG here. You can click on the exe file, or if you're on Windows, or you can click on any other file if you're on other operating system. And once you unpack that file, then the setup should be really straightforward as a next kind of wizard. So I will simply download this as a DMG on my computer, and it should install shortly. You can pause the video if you need. All right, now after you download the file, you should simply click on it. If you're on Windows, you should be greeted with a simple wizard. I have a simple package here, which I'm going to double click and install the JDK, which looks like this. So you will see something like this wherever you are, whichever platform you use, whichever operating system you use. So I'm going to hit continue and then install. I'm going to hit on my credentials, and then the Java development kit will install very shortly. All right, so I've installed JDK 14 on my computer. Now, if you need some more time to install JDK, you will need to follow an exactly identical next kind of wizard. If you need, you can pause the video to do that. All right, now, after you install JDK, which comes after this wizard, you will need to install a development environment with a code editor and a compiler so that you can write some Java code in a text file, and the compiler will turn that into an actual Java application. And for this tutorial and for all the trainings that I hold, I recommend using JetBrains IntelliJ IDEA, the development environment for Java and the JVM. So you will need to go to jetbrains.com/IDEA. And after you do that, you will be greeted with this IntelliJ IDEA homepage, and you will click on this download button, and then you will download the community edition for Java. I already have it installed, and if you need, you can simply click this button and it will install a small file which will trigger an identical wizard with a next, and you will be ready to go. Now, if you need more time, you can of course pause this video until you have IntelliJ IDEA installed for your platform. After you install IntelliJ IDEA and open it for the first time, the window will look something like this. So it's a small window, and on the left-hand side, you will have all the projects that you've created. Obviously, you may not have anything here on the left-hand side, but you can simply click this button to create new project. And when you click on this button to create a new project, you will by default have Java selected here on the left-hand side, which of course I will recommend that you select as well. And make sure the project SDK is not empty. And IntelliJ will usually be smart enough to identify the JDK, the Java development kit that you just installed. And I have here 1.8, but I can point to the 1.14 that I installed earlier. So I have here JDK 10, JDK 14, and JDK 1.8. So you will need to click on this folder over here and select it if the drop-down list is empty. So make sure the project SDK points to a Java version. You can pick any Java version you like. For the rest, you can leave empty and just click on Next. You can create a project from template, so you can tick this box, and you will leave the command line app selected already. So you will click on Next. You will name this project however you like. I will create this as Java tutorial, and I will point this into a folder that I have here on my computer, and the base package will be com.rockthejvm. You might have something different here. I recommend that you use com.rockthejvm as a standard naming for the base package. I will explain what this naming actually means, okay? So click on com.rockthejvm, so write com.rockthejvm here, and then hit finish. The directory does not exist. IntelliJ will offer to create the existing directories for the project, so click OK, and then you will be greeted with this window in which you have a piece of code already generated for you by IntelliJ IDEA. All right, now let me go ahead and make this window a little bit bigger, and let me make the code a little bit bigger by switching to presentation mode so that you can see the code more clearly. Now, we have a bunch of blank space in which we are going to write most of our code, and if you hit Command 1 or Control 1 if you're on Windows, you will notice the File Explorer here on the left-hand side. The File Explorer contains all the directories and files related to the project that you have created. Most of the files and folders are useful for the development environment only. We are going to be spending most of our time in the source folder, the src. And under src, the source folder, we have what is called a package. A package is just a folder on your file system in which we are going to organize our code. So in Java, we write quite a lot of code in practice. And because we write quite a lot of code, it's useful to compartmentalize that into files and folders. In Java, we call those packages. And these packages have a special naming convention that we tend to follow. And we generally follow the naming convention in the reverse style in which we write websites. For example, rockthejvm.com becomes com.rockthejvm, and then we can create some additional sub-packages under rockthejvms. For example, if I want to create courses and blog, I would say com.rockthejvm.blog and com.rockthejvm.courses as a standard naming convention for how we create packages in Java. So when you create the package com.rockthejvm, underneath the source folder, there will be a folder called com, and under the com folder, you will have another folder called rockthejvm. And here under com.rockthejvm, we have a file called main.java. So if you are curious enough to explore the file structure of this Java tutorial folder, you will have a text file called main.java. And the Java file is the text file where we will write our code. And if you explore main.java, you will notice that the first definition, the first piece of text that this code contains is a package definition. So we write package com.rockthejvm. This is automatically generated by the development environment. You can also write this manually, but most often you don't need to. And here in this text file, we have what is called a class that we called main, and we have what is called a method called main with a small m. So we have main with a capital M and main with lowercase m. We will understand what a class and what a method and every single one of these words on the file will mean. All right, so for now, don't stress about it. We will explain everything that we need to run a program. So the great text that we have here on the screen is called a comment, and a comment is a line that starts with a double slash. A comment is very useful because a comment describes what a code will do. This particular piece of text will not influence the running of the program, but it's useful for us to understand what a piece of code will do when reading a certain file. All right. So I'm going to keep my indentation at 4 spaces, and I will write the following so that you execute your first Java application. I'm going to write system with a capital S dot out dot println, so that is called print line, and open and close some parentheses, and inside the parentheses you will open and close some quotes. So when you write a quote, the IntelliJ IDEA will automatically insert the corresponding closing quote, and inside the quotes you are going to write I'm learning Java. So you can write any piece of text that you like, and at the very end of the line, you will put in a semicolon. Now, this semicolon is very useful. If you don't put a semicolon, then the development environment tells you that a semicolon is expected. A programming language is just a piece of text that will follow a certain set of rules. And so if you want to learn the Java programming language, you will need to understand and follow the Java rules for writing code. So once we write system.out.println, I'm learning Java with a semicolon, this particular code is valid and we can execute it. So if you right-click on the file and you click on this button to run main, the compiler will start to compile this code and turn it into a Java executable. And notice that in the console here at the bottom, you will print I'm learning Java. So your text was reflected into the console below. The console is a place where you will be able to input and output pieces of text, and we will interact with the console quite a lot in this tutorial. All right, so the programming language Java has a certain set of rules, and the development environment is smart enough to highlight the rules for you. So for example, these orange words are called keywords because they are part of the language specification. The yellowish, the light orange one, these are called methods, and we will learn what they are later. And every single one of the colored piece of text that you see here on screen has a different meaning, and we will learn that meaning shortly. And we will start with variables. So variables are pieces of information that we need to run our programs. Variables have the following structure. So write exactly as I write here on screen. Int, this is an orange keyword, so int needs to be written exactly like that. And I'm going to define a number, written a number with a capital N, and I'm going to put an equal sign, and then I'm going to say 2, and then put a semicolon at the end. So every single line in Java will need a semicolon just as a rule. So in this way, I've defined a variable. A variable will contain the type of the variable. In this case, we have int, which is the type for integers, the name of the variable, and I've named it a number. You can name this however you like, and then the equal sign, and then the value that we associate to this name. So when you write something like this, the computer will allocate enough memory to store an integer, and inside that memory zone, it will put in the value 2, the number 2. You can create another number. So you can find, for example, int another number equals 40, semicolon. So you can define as many variables as you like, and these variables are pieces of information with which we can write our programs. Now, bear in mind that the names of the variable will matter. So a number is different than int a number equals 45. So a number written like this and a number with a capital A will be different variables. You will not be able to define two variables with the same name. So if you write something like this, then this is a compiler error, and the IntelliJ will give you an error. Variable a number is already defined before. You can only use a variable name once. So I'm going to remove this line. All right, let me give another variable. Let's call this int sum, and equals, and on the right hand side of the equal sign, which is the assignment operator, you will put in an expression. So you can define mathematical expression between these two variables. So I'm going to say a number plus another number, semicolon. So when you define something like that, the computer will allocate enough memory to store an integer, and inside that memory zone, the computer will put in the value obtained by summing up the other two values, 2 plus 40. So this sum will be 42. All right, so notice that I've added a comment here. You can put in a comment even after the end of a line. So when you write a double slash, this piece of text doesn't matter for the rest of the code. But I've added it here so that we can explain what's happening inside this code. Now, if I do system with a capital S dot out dot println. So this is system.out.println. And if I printline sum and hit a semicolon at the end, I can of course run this program, and the value of the sum will be printed to the console. So if I run this application, right click and run this, we will have the value 42 printed to the console. So notice that you can define any variables that you like, and you can tell the computer to do any particular mathematical operation between these variables, and if you print that out, then the computer will compute that and it will show it to you. This is pretty powerful stuff. So let me teach you about primitive types. When you define a variable, you tell the Java virtual machine, the JVM, that is the computer, to allocate the certain amount of memory to store that particular value. And each type for example, the int, has its own format and its own standard size. And the more information you need, the more memory you will need. So let me define various primitive types. So we've defined integers before. So int an integer equals 30 with a semicolon. So this will be an integer, and an integer will be stored on 4 bytes. So pretty small. And because there are 4 bytes, you cannot store any large integer, for example. The more digits you have, the more memory you will need. And 4 bytes is only good for integers up to roughly 2 billion in size, all right? So if you write int a big integer and you put in a certain very large number, then this is a compiler error because this number is too large for the int size representation. And IntelliJ will tell you that. If you want to define a bigger integer than this, you have the type called long. Long is also a keyword and needs to be written exactly like this. So long, a big integer, and when you write something like this and put an L at the end, the L signifies that this number is a long, and a long will be on 8 bytes. 8 bytes is roughly 9 quintillion, so you can define pretty big numbers that will fit into 8 bytes, and 8 bytes is still quite small. All right, now we can also define decimal types. So I will define a decimal type known as float. Float is a shorthand for floating point decimals. This is a binary representation of decimals inside the binary computer, which is only based on ones and zeros. So I'm going to define a small decimal as 2.3, so 2.3, and then I'm going to put an F at the end, and then a semicolon as usual. So this F marker is a sign that this decimal is a float, and a float is 4 bytes each. Now, if you want to represent very small numbers and very big numbers, that will incur some extra information. So remember, it's not the size of the number that is important for a representation, but the actual amount of information that is needed to store that particular number. And so very small numbers and very big numbers in decimals are outside the 4 byte scope. And for that, we will need double. Double means double precision. That is why this particular type is called double, and I'm going to define a big decimal as 3.14, and just like that, without any other marker at the end. 3.14 is roughly the value of pi, and this is double precision. And this is 8 bytes. And 8 bytes is enough to store very small decimals and very big decimals. For example, if I define a double number of stars in the universe, this is roughly 1.1, and then I'm going to use an exponent notation, E21, and a semicolon at the end. So if I do 1.1 E21, that is 1.1 times 10 to the power of 21. So 1.1 billion trillion, if I do my math correctly, this is the number, roughly the number of stars in the observable universe. So notice that this number is absolutely humongous. And you can also store very small numbers. I'm going to define another double. Let's call this hydrogen radius as 5.3 E negative 11. So E negative 11 means 5.3 times 10 to the power of negative 11. So that's 53 picometers. That is the radius of the hydrogen atom. So notice that this is also a very small number. These numbers are both not representable with doubles. All right, cool. So these are numerical types: int, long, float, and double. These are the most widely used in the Java programming language. Now, Java supports other types for variables, and I'm going to show you the character type defined by char. You can pronounce it char, from character. And char, you can define a character equals, and character values are literals like A, B, C, and D separated by small quotes. So I'm going to put in quote A and then a semicolon at the end. So the quote A is a character, and inside the small quotes you can put in a single character. If you try to put in too many characters, this is a compiler error. So you have too many characters in character literal. You only can put in a small character inside double quotes. You can also put in digits inside the simple quotes. So I'm going to define a digit character as quote 1, for example. And I want you to pay very close attention and make the difference between quote 1, the character, and the number 1, the integer. So don't confuse 1 with 1. Now, the final type that I want to show you for primitive types is called boolean. Boolean comes as a tribute to the mathematician George Boole, which defines some arithmetic on working with truth values. So I'm going to define a truth value equals, and on the right hand side you can put in either true or false. The words true and false are keywords in Java. And keywords in Java are useful because they are reserved words for the Java language. You cannot name your variables, for example, true or false. That would be a compiler error. So these orange words are reserved for the Java language. You cannot use them to define names, all right? So these Boolean values store truth values, and you can use truth values to make the program decide what to do depending on those truth values, and we will see those later. So notice that we named these variables in a certain format. So in general, we use what is called camel case notation. The camel case naming convention states that if you name something with multiple words, you write the first letter in lowercase and subsequent letters of composite words in uppercase. So N stars with a capital S, in with a capital I, the universe with a capital T, universe with a capital U. All right. So this is called camel case notation, and it is a good standard naming convention for the Java programming language. So try to name your variables in this style and give the variables descriptive names so that somebody reading your code can understand what those variables mean. All right. So these are some naming pieces of advice that I can offer you as a software developer. Now, I will put in a special type called the string here, which is not a primitive type. It is a special type, and I will discuss strings later, but we will need strings as we go through this tutorial. So I'm going to define the string type string with a capital S, and notice that the string with a capital S is not a keyword. It is the name of a type, much like int, long, float, and double, and so on and so forth. So I will define a string as a piece of text that is separated by double quotes. So unlike characters which are separated by single quotes, you can put in any kind of text here. So for example, I love Java. And of course, make sure to end this line with a semicolon like every other line. So I will not stress you with semicolons from now on. I will assume that you will put in semicolons after every single instruction in this program. The more Java code you write, the more the semicolon reflex will become second nature to you. All right, so make sure you end up every single line with a semicolon. Cool. So these are the primitive types and the string type that we are going to use in our code. Now, in programming, besides being able to define pieces of information in various types, we can obtain some new results off of them. So I will define expressions. And the first expressions that I'm going to define is math operations. So I'm going to define an int. This is an int variable. I'm going to call this multiply int, as in equals 2 times 3. And the times operator, the multiplication operator, is the star. And 2 times 3 obviously equals 6. If you want to divide, you can say 7 divided by 3, and the division operator is the single slash. Now, division is very interesting because if the operands 7 and 3 do not divide exactly, only the quotient of this operation is kept. And so divide int will equal 2. So for integer division, only the quotient is kept. If you're interested in the remainder of the division, I'm going to define another variable here called remainder int as 7, and I'm going to use the percent operator. When you say 7% 3, this is called the mod operator, and this is the remainder of the division of 7 and 3. This is interesting if you've never seen this kind of code before. So this is the remainder of the division. All right, so the mod operator is very useful to determine whether two numbers divide exactly. So for example, if you want to test whether a number is odd or even, you can compare, and we will learn comparison shortly, you can compare the result of 7 mod 2 with 0. So if a number mod 2 is equal to 0, then it means that that number divides by 2 exactly, and so that number is even. All right, so these math operations are very interesting. Obviously, we have plus and minus, and I'm pretty sure you can intuit what they do. All right, I'm going to talk about incrementing and decrementing. Incrementing and decrementing are very interesting because they are applicable to programming languages in particular. So they are not necessarily mathematical operations, but rather programming instructions. So if I take my number, a number, and I want to increase its value by 1, I can say a number plus plus. So I can say something like this and put a semicolon at the end. This instruction means that the computer will take the value of the number and it will increase that value by 1. So after this instruction, a number will become 3 instead of 2. So we say a number plus plus because it's very easy for us programmers to simply increment values. And incrementing values is very common in programming languages, as we will see shortly when we are going to learn iteration. You can also do plus plus a number and a semicolon at the end. So plus plus a number does the exact same thing. It will take the value of the number, so the computer will take the value of the number, increase it by 1, and place it into the same memory zone that a number was used. So a number will become 4. So notice that in time, we can change the values of our variables. This is very interesting. And the way that the computer will actually execute a piece of code is that the computer will take these lines that are separated by semicolons one by one, and it will do exactly as the code will say. So if we defined a number equals 2, then the computer will find this instruction, a number plus plus, and so a number will become 3. And then it will find the next instruction plus plus a number, and the number will become 4, and so on and so forth. And so we can make the computer modify and change these variables over time so that we might end up with some useful information and results. And this is the power of programming. Now, post-incrementing like a number plus plus and pre-incrementing like plus plus a number are similar in that they increase the value of a variable. However, they're different if we want to use the result of the expression. Let me give you an example. So if I define int some integer equals 4, put a semicolon, and then if I want to define another integer, let's call this some integer 2, you can also include numbers in the names of variables. And if some integer 2 is some integer plus plus, the value of some integer 2 is still 4, although some integer plus plus will increase the value of some integer. Now, why does that happen? Well, post-incrementing will increase the value of a variable after that variable is being used. And so some integer becomes 4, after which some integer becomes 5. All right, so first, some integer is being used to take the value of some integer 2. So some integer 2 will become 4. And after that, some integer, the first one, will become 5. Not so if we define another some integer 3 as plus plus some integer. So I'm going to put a semicolon at the end, and this runs the operations in reverse order. So some integer becomes 5 in this case, after which some integer 3 becomes the value of some integer, which is at this point 5. All right, so plus plus some integer is called pre-incrementing because the value of this variable is incremented before the variable is being used, and post-incrementing allows the variable to be used, and after that it will increase its value. So make the difference between pre-incrementing and post-incrementing. So I'm going to put a comment here. Pre-increment and post-increment. And the same thing happens with the decrementing operator minus minus. So same, I'm going to put a comment here, same for minus minus, which is called decrementing. All right, so you can say a number minus minus, and it will decrease the value of a number in the same style as plus plus earlier. Cool. Now, let me show you math operators on decimals. So if you define a double, let's call this a double sum, as 2.3 plus 4.5. This is a regular math expression on decimal numbers, and plus, minus, and multiplication works exactly the same as on integers. However, the division works differently. So if you define double, let's call this divide double, as 7.0 divided by 3. 7.0 divided by 3, it will be a decimal number. So this will be different than 7 divided by 3. So divide double will not have the same value as divide int, because as I mentioned earlier, 7 divided by 3 only holds the quotient from the integer division. So this will be exactly 2. However, in decimal land, this will actually be a decimal value. So this will be 2.3333 and endless 3. All right, so this will be an endless amount of 3 up until the double representation limit. So you will see 2.333333 up until the double usual precision. Cool, so that was for decimal numbers. Let me show you character operations. Let me define a letter as car a letter as quote a. So you learned how to define characters earlier. And we can also use incrementing and decrementing for letters as well. So if I say a letter plus plus, this is also valid because characters are also represented in binary on the computer. And so they can be thought of as numbers, and they are represented as numbers due to what is called an ASCII code. ASCII is the standard representation of characters in a single byte. So if you hit ASCII on Google, you will learn the numerical codes for every single character that we usually use. All right, so all the characters for the Latin alphabet, all the digits, new lines, and so on and so forth. And we can increment a letter, meaning that we increase its ASCII code. And the Latin alphabet letters are in increasing order. So if I do a letter plus plus, then a letter will become B. Now, because we're in character land, let me show you some special characters. So first of all, let me start with a question. Because we can write characters in between single quotes, my question to you is, how would you represent the quote character itself? If you try to do car a quote as 2 quotes and inside you would put in a third quote, that would not be possible. And this will be a compiler error because the compiler is confused at this point. When you write double quotes, then the compiler expects to see a third character in between these 2 quotes. And so you cannot really put in 3 quotes in turn. The way that we represent a quote character is to put in a backslash inside. This is called an escape sequence. And when you write backslash quote, then the computer will know that you in fact want to write the quote character itself into these 2 quotes. So when you say backslash quote, this is the single quote character. So backslash quote is the quote character. There are certain backslash escape sequences that are very useful in practice. Let me do the double quote, which happens to have an escape sequence very similar, backslash double quote, simply like that. So this will be the double quote. You can also have the character new line, which is very difficult to represent on a piece of text because when you hit on enter, you will actually trigger a new line in this text editor. And so how do you represent the new line itself? Well, you would define a character called new line as backslash n. So backslash n is a special character called new line. This is if you try to print something with a backslash n, then the computer will understand that backslash n will trigger a new line. And so if you say string I love backslash n Java at the top here, then Java will be printed on another line if you try to print this to the console, all right? So backslash n is again a special character. Another special character is a tab, which is an indentation, and this is represented as backslash t. So this is a tab. And if you want to represent the backslash character itself, you represent that as backslash. So if you print I love backslash Java, then a single backslash will be printed to the console. All right, so these are special characters if you want to print something very interesting to the console. So remember these. Now, finally, let me show you some boolean operations. All right, now, boolean operations are very critical for us programmers because we can tell the computer to do something or something else depending on the values of some boolean operations. So I'm going to define a boolean variable, and I'm going to name this number is too big equals, and on the right hand side of this assignment operator, I'm going to give it the value a number bigger than 100, and then I'm going to put in a semicolon at the end. What does that mean? On the right hand side of this equals operator, the equals, as I mentioned, is an assignment operator. On the right hand side, we have an expression, and the expression, a number bigger than 100, can either be evaluated to true or false, depending on the value of the number. So the number that we have here equals 2, and we've incremented it a couple of times, so a number becomes 5 or 4 or something like that. So a number bigger than 100 is an expression that will evaluate to false. Actually, I'm going to not use the double quotes because the false is not a string, is an actual value of type boolean. If you remember earlier, the truth values can be true or false. And in this case, we have an expression that evaluates to false in much the same style as the addition of 2 numbers evaluates to another number. And so this expression evaluates to false. Let me define another boolean. I'm going to create another boolean. Let's call this is letter my favorite. And the value of this variable is going to be the equality test case. So I'm going to say a letter equals, and I'm going to put in double equals, and I'm going to put in another character. Let's say T. That T is my favorite letter. So do not confuse the equals, the single equals operator, which is an assignment operator, meaning that this variable takes the value of whatever is on the right-hand side, with the double equals, which is the comparison equality operator. So this is very important. Equals means the comparison equality operator. So when you want to compare something to a certain value, so if you want to test whether a value is equal to something else, you would put in double equals, never a single equals. So this is very important, and this is a common source of mistakes for beginner programmers. So double equals tests whether the left-hand side of the double equals is equal to the right-hand side of this operator. So a letter equals t in this case returns false, and this operator returns false as well. And this is the value that is being associated to the variable that I called isLetterMyFavorite. And you can chain these Boolean operators via logical operators. So we can say Boolean, let's call small odd number equals, and on the right hand side we want to compare whether a number is even and whether a number is small. For example, if it's less than 10, we can say a number less than 10. So you can use greater than, smaller than, and you can chain with and two ampersands. And in another set of parentheses, you can also define another condition. For example, a number mod 2 is equal, that is the comparison, to 0. Now, this expression is quite complicated. So what does that mean? A number less than 10 is an expression that evaluates to either true or false. In our case, it evaluates to true. A number mod 2 is a mathematical expression which evaluates to the remainder of the division between a number and 2. And this remainder must be compared to be equal to 0. And this final expression is also a Boolean. And so in this composite expression, we have two Booleans, a number less than 10 and a number mod 2 equals 0, which are chained by this AND operator. And you can read this whole expression exactly as it is. A number less than 10 and a number mod 2 is equal to 0. And this final expression will also evaluate to either true or false, and in our case, it will evaluate to true. You can use the AND, the ampersand, to chain Boolean values. And you can use the OR operator, as in this double vertical bar, to chain Boolean values with the OR operator. So you can say a number less than 10 or a number mod 2 is equal to 0. And you can define custom logic in your program by chaining the Boolean values with these ampersand, and the double bar operators. We're going to test these operators later in this tutorial. So for now, just remember that you have ampersand for AND. This is logical AND. And you can have the double bar for logical OR. Okay, so keep these in mind. You can also negate Boolean values. So let's say Boolean negate as bang. This is the exclamation mark, and you can use another Boolean value. So not small odd number will simply negate the truth value of the small odd number. So if the small odd number is true, then this will be false. And if small odd number is false, then the negate will be equal to true. All right. So you only have two truth values in the Boolean logic, and you can simply switch between them with this bang, with this exclamation mark operator. We're going to test these in the rest of this tutorial. So remember the Boolean operations because they are critical for general programming. We can make the program decide what to do depending on the values of these Boolean operations. I'm going to show you some string operations. So I will define another variable of type string. So I'm going to define a string, let's call this concatenation. And on the right hand side of the equals, I'm going to say double quote I love, and I'm going to put a space here inside this string. And then I'm going to write plus, and then I'm going to pass another string. And I'm going to say Java with an exclamation mark and semicolon at the end. Now, what does plus do in between two strings? Where for mathematical numbers, or as a mathematical operation, plus would simply add two numbers. For strings, the plus operator simply concatenates strings. So in our case, we have I love space Java, and so we will return the string I love space Java with an exclamation mark. And it's worth noting that the plus operator will return another string. So these two strings will not be modified, but the result of this operation will always be another string. Okay, so concatenation will take the value of I love Java, and by this point it's worth printing out something. So I'm going to write system with a capital S, so system dot out dot println, that is print line, and let me print concatenation, obviously with a semicolon at the end. So if you run the main class, the Java compiler will compile this code, and notice that the program will print I love Java, this single string, because these two small strings were concatenated. Now, as a trick in IntelliJ, you can simply write s out, so s out like this, and hit on enter, and IntelliJ will automatically complete the system.out.println statement for you, and then it will move the cursor inside the parentheses for your convenience so that you can print any kind of value that you like. Okay, so we are going to use this shortcut in the rest of this tutorial. All right, now we've talked about a lot of stuff. Now I'm going to teach you something that's very critical to programming, which is instructions. Instructions are necessary for programming because the computer will follow exactly what we write in this code, line by line, or instruction by instruction. So every single line that we wrote here separated by a semicolon is called an instruction. And something that's very critical for us programmers is to be able to change variables. So you can change variables in subtle ways by incrementing or decrementing them, or you can change them in very dramatic ways. For example, I can say a number equals 45. Now, the equal sign you can read as becomes. So this instruction can be read as a number becomes 45. And when you read it in this way, several instructions are very easy to read. For example, I can say a number becomes a number plus 6. So when you say something like this, you can read this as the new value of a number becomes what's on the right hand side. And what's on the right hand side is the old value of a number plus 6. So a number becomes 51. At first, nobody explained the becomes rationale to me. So when I saw this particular line in my first programming class, I was going crazy because it didn't make any mathematical sense. Nobody writes a number equals a number plus 6 because it's mathematically incorrect. But equals doesn't have the mathematical meaning. It means becomes. So you say a number becomes a number plus 6. Now, a shorthand way of doing the exact same thing would be to say a number plus equals 6, which is the exact same thing. All right, so when you say a number plus equals 6, you actually are saying a number becomes a number plus 6. So these are several instruction examples that will allow you to change the values of the variables that you defined beforehand. And you can change the values of any variable that we defined all the way to the start of the code. So for example, from a truth value to true, you can say a truth value equals false at any point in your program. So at any point you can change the values of the variables, and so you will change the state of the information that the computer has access to from your code. Now, Something very important to bear in mind. When you write something like this, when you say a number equals a number plus 6, if you go all the way to the top, when you define the sum variable as being a number plus another number, if you mutate or if you change the value of a number, which was the constituent of a sum that you wrote all the way to the top of the code, the value of the sum doesn't change, because at the very beginning, when you defined int sum equals a number plus another number, the value of sum takes the value of the right-hand side at that point. And because a number equals 2, you can't simply say a number equals 45 and expect sum to automatically update. So sum will keep its value 42 because it was the value that it became at this moment, at line equals 12 in my screen. If you want to prove it, you can print the value of sum after you mutated the number 45. So we can say sout with the shortcut that we learned a few minutes ago, and we can print out sum. And even though we mutated, if we changed the number to be 45, the sum will keep its old value 42, and we can prove it by running our application. So right-click Run, and we will see the same value 42 in the console. So old variables don't update automatically. We need to update the old variables ourselves if we want them to take another value. Cool. So let me show you some other stuff. I will show you control statements. So in order to write meaningful programs, we need to have some tools to make the computer decide what to do depending on some values. So I will define a small variable of type int. I'm going to say int age equals 28, which is my age at the moment of this recording. So I will write as follows. So right after me, if, which is a keyword, and then open parentheses. And inside the parentheses, we will put in a boolean expression. So I will say age less than 30. And I will open a curly brace, and when you hit on enter, IntelliJ will automatically put in a corresponding closing brace. And inside these two curly braces, I'm going to do sout, so system out print line. I'm going to say you're just getting started. And after the curly brace, after the closing curly brace, I'm going to say else. And then I'm going to open another curly brace and hit on enter, and IntelliJ will automatically put in a corresponding closing brace. I'm going to say sout, and I'm going to print perfect time to start learning Java! Exclamation mark. So what have I written here? This whole expression, this whole structure over here is called an if-else statement. And an if-else statement is a way to instruct the computer to decide to do different things based on the value of this Boolean expression. And because the age variable is equal to 28, the condition here will be true. And because the condition will be true, the instructions inside these two curly braces will be executed by the computer, and the other instructions will be ignored. All right, so because age is less than 30, because its value is 28, the instructions here will be executed by the computer and these will not. Otherwise, if age is, for example, 78 instead of 28, then the first set of instructions is ignored because the condition is false, and the other set of instructions will be executed by the computer. And so notice that depending on the values of our variables and depending on the conditions that we as programmers set, the computer will do different things. And this happens in real life all the time. So for example, if you consider the like button on Facebook, if you have never clicked a like button on a picture, then if you click the like button, then you will add a like to the picture. If you have clicked it, if you click the like button again, then you will retract your like or your reaction to that particular picture. And so the computer will do different things based on the information that it has at that moment. In other words, it will do different things based on the values of the variables at that point, which is what we are doing here. And so if we run this application, we will see perfect time to start learning Java. And so the system out print line on line 78 was ignored because the condition was false. And so remember the if-else statement structure. If with a condition inside parentheses, and if the condition is true, then the expressions in the first set of curly braces will be executed and the others will be ignored. If the condition is false, then the other set of instructions will be executed and the first set will be ignored. All right, and you can put in multiple instructions inside these two curly braces. So for example, I can do system or sout something else. And I can also add some other instructions. For example, age plus equals 1 if I want to change the age by 1. And so I will sout and say your age has become, and I will add age, meaning that I will concatenate age to this string. So notice what happens if I run this application as it is. So notice that we say perfect time to start learning Java, and all the other instructions are also executed because I said that this whole block is being executed if the condition is false. So if the condition is true, then the first block will be executed, otherwise the other block will be executed. And in our case, the other block got executed. So perfect time to start learning Java was printed to the console, age increased by 1, and then we printed out your age has become plus the value of age, which has changed from 78 to 79. Now, these if structures are so powerful that you can also chain them. Let me give an example. Let me define a variable called temperature as being 22. 22 degrees centigrade is pretty pleasant as an air temperature outside. So I'm going to write as follows. If temperature is less than 20, then this is pretty chilly. So I'm going to print out, so sout, and inside quotes, I'm going to say quite chill outside, maybe take a jacket. All right, so with a semicolon at the end. Else, and I'm going to continue with another if. So else if the temperature is less than 25, which is my definition of pleasant. You might change this number to reflect your own preference if you want. So I can say sout, and I'm going to print another string. So I'm going to say very pleasant outside. Take a walk. All right, and else, and I'm going to open another set of curly braces. Else, I'm going to say sout. It's getting hot. Maybe take some water. Okay, so notice that this complex if-else structure was chained. If the temperature is less than 20, do this. Else, if this temperature is less than 25, then do something else. Otherwise, do something completely different. And so you can make the computer choose between multiple different options, not necessarily two different options like we had before. And if you click on this play button here to rerun the application, or if you right click and run the application, however you pick, notice that we made the computer decide very pleasant outside, take a walk, because the temperature is not less than 20, so it's not chill, but it is less than 25. And so we are printing very pleasant outside, take a walk, right? So I hope this makes sense. Now, the next thing that I'm going to show you is how to make the computer repeat something automatically. So I'm going to show you while loops. While loops may sound a little strange, but I'm going to show you what while and loop mean. So let me write the following. I'm going to say sout So I'm going to print something. So system out println, and I'm going to say, watch me count to 10, exclamation mark. And I'm going to define a variable int counter, starting with 1. So I'm going to say int counter equals 1. So I'm defining a counter and make it take the value 1. I'm going to say s out, and I'm going to print the value of counter. So I'm going to print the number 1. And throughout the rest of the program, I want the computer to automatically increment counter until it gets to the value of 10 and print every single value of counter in between. So notice what I'm going to do. I'm going to say counter plus plus. So I'm incrementing the value of counter by 1, and then I'm going to print it out again. So I'm going to say s out counter. So now the counter has received the value 2. So system out println counter, the first one printed the value 1, then the second print showed the value 2. Now I'm going to copy these 2 lines of code, and I'm going to paste it the remaining 8 times. So I'm going to say 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have quite a lot of code that prints the numbers 1 through 10. And if you run this program, if you right click and run this, you will notice that the computer will automatically print all the numbers between 1 and 10 really, really, really fast. Cool. Now, this is all well and good in theory because we are counting to a relatively small number, but what if we needed to count to 100 or 1,000 or 1 million? What do we do? Do we copy this code all over again and have a code that is 1,000,000 lines long? There's got to be a better way. And a better way is to remove this and to introduce a tool in the programming toolkit that Java provides, which is called a while structure. So I'm going to say while, and I'm going to add a set of parentheses, much like we did for if statements. And I'm going to say while counter is less than or equal to 10, and less than or equal is denoted by this sign, so less than or equal. And then I'm going to open and close some curly braces, much like we did for the if statement. So I'm going to s out counter. So I'm going to print the value of counter, and I'm going to say counter plus plus. So I'm simply going to write it like this. So here's what this structure is all about. As long as counter is less than or equal to 10, the computer will run these instructions inside the block denoted by the curly braces. And so counter starts with 1. And so because counter is less than or equal to 10, the computer will run these 2 instructions. And at the end of that, counter becomes 2. And then the computer will come back to the condition is counter less than or equal to 10, and it will run these 2 instructions over and over and over again until this condition turns false. And so if we run this application, notice we have the same 10 numbers printed to the console, but automatically. So the computer did that automatically for us. And the best part is we can increment or change this number to as big a number as we like, and the computer will simply run the same code over and over and over again, and it will count to 1 million if we wanted. So notice how easy it is to make the computer do some repetitive tasks automatically without having us to copy and paste the code over and over and over again. Now, this structure is called a while loop because the structure starts with the while keyword. Notice it's orange, and it's a loop because the computer will run these instructions over and over and over and over and over again as long as a condition is true. The computer can do some repetitive tasks in a number of ways, and the while loop is one option to make the computer do some repetitive things over and over again. Another option is to do while loops. Now, do while loops look a little bit differently. I'm going to restart the counter to 1. So I'm going to say counter becomes 1. And I'm going to write as follows. I'm going to say do, and I'm going to open and close some curly braces. And I'm going to say sout counter and then counter plus plus, much like we did with the original while loop. And after the curly braces, I'm going to add the while after. So I'm going to say while counter is less than or equal to 10, and a semicolon at the end. So notice that unlike the while loop, the do while loop has a semicolon at the end. The do while loop operates in a very similar way. So if I run this application again, we will see the numbers 1 through 10 printed over and over again. So we have the numbers 1 through 10 from the first while loop and the numbers 1 through 10 printed again from the do while loop. Now this loop is called the do while loop for obvious reasons, because it's marked by the do and the while keywords, and it's called a loop because it repeats the same set of instructions as long as a condition is true. Now the while and the do while loops are different in the sense that the while loop tests the condition first before running the set of instructions, whereas the do while loop tests the condition after executing the instructions. So in our case, counter is equal to 1, and the instructions are run regardless of whether counter is less than 10 the first time. All right, so counter is equal to 1, and then it will do print line counter and counter plus plus, and then it will test is counter less than or equal to 10, so that I know how to repeat the set of instructions. So in while loops, we test condition, then execute. And in do while loops, we have execute, then test condition. All right, so these two are different in that sense. The do while loop is a little bit more rarely used. The while loop is most often used in regular software development. Now, the final expression that I want to show you for running repetitive tasks is a for loop. Now, for loops are notoriously difficult for beginners because they look kind of strange. So I'm going to write as follows, and I will explain what every single component of the structure will mean. So I'm going to say for, and I'm going to open some parentheses, and I'm going to say as follows. I'm going to say counter equals 1, semicolon, and then counter less than or equal to 10, semicolon, counter plus plus without a semicolon. And after the parentheses, I'm going to open and close some curly braces, and I'm going to say sout counter. Now, this structure will do the exact same thing as the previous two loops. So let me deconstruct what a for loop consists of. So I'm going to put these three components on separate lines so that you can see them better. A for loop starts with an initial instruction. The initial instruction sets the stage for the start of the loop. So basically what this for structure will start with is with counter equals 1. So this is the starting instruction. Now, counter less than or equal to 10 is the continuation condition. So it will start with setting counter to 1, and as long as counter is less than or equal to 10, then this particular set of instructions will be executed. And so this will be the contents to execute. After the contents have been executed, then the final instruction will be executed. So this is a instruction to execute after the contents. The for loop is notoriously difficult for beginners. So let me explain how a for structure operates. So I'm going to add a multi-line comment. So when you say /*, then this follows with a piece of text that does not contribute to code execution, much like single line comments with //. So I'm going to add a multi-line comment so that I can explain how for structures work. So this for structure works in the following way. Starting instruction. So I'm going to say execute starting instruction. Then as long as continuation condition, then you will run the contents, and then you will run instruction to execute after the contents. All right, so this is the for structure operation. All right, this is this verbal, this human natural language explanation is called pseudocode, because there is no programming language to actually run exactly what I'm saying right over here. But this is a human readable explanation on how a for structure operates. I hope this makes sense, and as you write more Java code, this for structure will become second nature to you because it's very, very widely used. And we are going to test this for expression, this for structure, when we write our little chatbot. All right, so just bear in mind that the for structure over here is identical or equivalent to the while structure with the initial instruction that we wrote at the beginning. The while loop is much more understandable for now, but we will rephrase while loops into for loops when we write our chatbot. All right, so if you want, you can pause the video and try to remember or make sense of these three repetition structures, because they are important in programming. All right, we're going to write our own repetitions in the rest of this tutorial. All right, so these control statements with if else and the repetition structures while, do while, and for make the bulk of general software engineering in general. All right, so these are very important to keep in mind. Now, let me show you something else. In real life, we work on very complex problems and we build complex systems, so we need to manage quite a lot of information, more than just simple numbers and strings and characters and booleans. And for this, we need to be able to work with our own data types, not necessarily with int, string, character, boolean, and so on and so forth. We need to define our own data types. So imagine that you're implementing a social network and one user sends a message to another user. This warrants the use of what is called a reference type. So as I mentioned, imagine that we have a small social network and one user sends a message to another user. So I'm going to define a string. Let's call this username1 as Alice. Okay, and I'm going to define another variable int. Let's call this user age1 as, let's say, 25. So Alice is 25 years old. And I'm going to define another pair of variables attached to another person called Bob, for example. So I'm going to say string username2 as Bob. And I'm also going to define int user age2 as 24, for example. So notice that we have two pairs of variables, each attached to a person that we call Alice and Bob respectively. And so let's print something as out. So I'm going to system out println, and let's assume that Alice says to Bob, happy birthday for turning 24. So I'm going to print a composite string. So I'm going to say username1 plus, and I'm going to add a space, says to space, and then plus username2. So Alice space says to space Bob, and I'm going to print this on a separate line. In Java you can do that, so you can separate the argument of print line on a separate line, and then I'm going to add another plus, and I'm going to add in the following string. I'm going to say colon space happy birthday for turning space and I'm going to add user age 2, and then I'm going to add an exclamation mark as a string. So what I'm printing to the console is to say, Alice says to Bob, colon, happy birthday for turning 24, exclamation mark. So this is a very long string. But notice that in our small social network, if we wanted to model it as such, we have two pairs of variables that are each attached to a certain entity that we imagine to be a person. So these two variables are attached to a person, and these two variables are attached to another person. In Java, we anticipate that in real-life code, we will often have the need to attach multiple pairs of variables to the same kind of quote-unquote entity that we call a class. In Java, we can define classes which can wrap multiple variables into a single type. And so at the very bottom, after the last curly brace, I'm going to define a class. I'm going to define this class as person. So I defined a class person with a capital P, and then I opened and closed some curly braces. Now, class names follow the same naming convention as variable names, except they usually start with a capital letter. So person is a good name for our class. And this class person will define the imaginary concept in real life of a person that has various kinds of information attached to it. For example, in our social network, it will have a string username and a semicolon. So I've defined the member or the constituent information of this person class. And I'm also going to define another variable, int, let's call this age, semicolon. And so by defining this person with these two variables, I've defined a data structure that contains two pieces of information under the same type. The username and the age that I've written here are called fields, which are pieces of information attached to a single type. All right, so we can simply say that a person has a username and an age. Okay, good. Now, what do we do with this person class? Well, we use classes to model the situation where we have multiple pieces of information attached to the same conceptual entity. And so instead of having two pairs of username and age, we can define two instances of this person class. So here's what we are going to do. We're going to instantiate or create an instance of a particular class. And so I'm going to define a variable, this time of type person. So I'm going to say person. I'm going to call this variable Alice with a smaller case a, so lowercase a, because this is a variable name. And I'm going to define a new person. Open and close some parentheses, and obviously with a semicolon at the end. What have I done here? I've instructed the computer to allocate enough memory for an instance of the person class. When you allocate enough memory for an instance of a person class, the computer will allocate enough memory for every constituent member. And so in one line, I've made the computer allocate enough memory for both fields of the person class. Now, when you allocate enough memory for a person class, we call that an instance. So Alice is an instance of class person. An instance means that it has some real physical memory allocated by the computer of the structure defined by the class person. So you can think of a person class as some sort of a blueprint of how the data structure looks like with these two fields, and an instance as a concrete realization in memory conforming to the structure defined by that class. All right, so a class is a data structure, and instantiating it is done with the keyword new, and then with the person with some parentheses here, and optionally with some arguments, as I'm going to show you shortly. Now, having instantiated this class in the instance Alice, we are now ready to set Alice's fields. So I'm going to say Alice dot username. So this means the username field of the instance Alice equals, and then I'm going to pass in a string like Alice, semicolon. So I've basically set the username field of the instance Alice to take the value string Alice. In the same style, I can say Alice dot age equals 25. So in just the same style as we said that a variable becomes whatever is on the right-hand side of the equal sign, in the exact same style, we are setting Alice's fields to take whatever value is on the right-hand side. In the exact same fashion, we are going to also instantiate the person class in the instance that we are going to call Bob as new person, parentheses, semicolon. So this is another instance of the person class. And then I'm going to say bob.username equals Bob, semicolon, and Bob dot, and notice that IntelliJ automatically popped up this small window. You might have seen this before. And if you double click on the field age, IntelliJ will automatically complete the rest of the text for you. So this is pretty convenient. So bob.age equals 24. Now I can move the system out print line below. So I'm going to cut it and I'm going to paste it down below. And I'm going to remove these two pairs of variables. And notice that the compiler is now unhappy with me because username 1 and username 2 are not available anymore. They're not being defined, so cannot resolve symbol username 1, but instead I can use alice.username. So alice.username says to bob.username, happy birthday for turning, and then instead of user age 2, I can say bob.age. All right, so instead of the previous variables, we can use the fields of the different instances of the person class that we defined beforehand. Now, this person type, this person class that we defined here is called a reference type. We call this a reference type because when you say alice.something, the computer will refer to the data structure that will contain multiple fields. And this is why the class, or any class that we define ourselves, is called a reference type rather than a primitive type. So when you instantiate a reference type, the computer will simply allocate enough memory to store the fields, and it will return some sort of pointer. It will store the address in memory where those two fields are being located. And so because the computer needs to refer to that memory zone, that composite memory zone, we call custom classes reference types. The string type, as we wrote way at the top of the code, where did we write that? The string type, notice that I left it outside of the primitive types because strings are reference types. And we will understand how reference types are fundamentally different than primitive types when we enhance the capability of this person class. And here I'm going to write the following structure. I'm going to say as follows. I'm going to say public. And we are going to investigate what public means in a moment. So I'm going to say public, and I'm going to use person, the exact same name as the class. And I'm going to open some parentheses. And notice that IntelliJ has automatically auto-colored this person word in something like yellowish orange. This is called a constructor, and a constructor can take arguments, and the arguments of this constructor, I'm going to name them as string user name and int user age. And I'm going to open and close some curly braces. Now, this structure is particularly important and looks like something very new. Now I'm going to go ahead and write a bit of code, and then I'm going to try to explain what this structure will mean. It might be a little complicated, so I'm going to ask for your attention, all right? So bear with me here. Inside the curly braces of this weird structure, I'm going to write as follows. I'm going to say username equals uname, semicolon, and age equals uage, semicolon. Now, after I've defined this strange structure, the compiler will yell at me saying that these two are now compiler errors. And instead of saying alice.username equals Alice and alice.age equals 25, I'm going to pass in Alice and 25 inside the parentheses for this person construction structure. So I'm going to say Alice and 25. And I'm going to remove these two lines. And then for Bob, I'm going to use very similar values. I'm going to say Bob and 24. And I'm going to remove these lines. Now, the compiler is happy with me. And the reason why the compiler is happy with me is because this structure over here, this weird structure, is called a constructor. This constructor takes a very weird structure. It takes an access modifier of which we are going to learn in a moment. And then the name of this constructor needs to be identical to the class name. And for us, we have the person class. Inside parentheses, we have so-called arguments that we can then use inside the constructor code to initialize the fields with whatever values we can actually pass with the names uname and uage. In other words, when I say person Bob equals new person with Bob and 24, when I write something like this, the constructor will be invoked with the values, the string Bob and the value 24. And so for Bob, the bob.username will be Bob, and bob.age will be 24. And so these parameters over here, these arguments, will take the values that I pass here on the other side. So when I write something like this, like new person with Bob and 24, the computer will allocate enough memory for a person data structure. And these values, the string Bob and the value 24, will replace the names uname and uage. And so once the person that I called Bob is being constructed, the value for uname will be Bob, and the value for uage will be 24. And these values will be used to initialize the fields of the Bob data structure. So I wrote them here to illustrate how the values are being copied by the computer so that you can use them to initialize this instance's fields. So I'm going to do some undos here so that the code can compile. So when you write something like this, the values Bob and 24 will be used instead of these names uname and uage, and these values will be used to initialize the fields username and user age as I wrote here in the code. So constructors are used to initialize fields. All right, and the structure of a constructor looks something like this: public, the name of the class, and some potential arguments. If you don't write any potential arguments, then you need to write as we did earlier with a new person, empty parentheses, because the constructor has no arguments. But I'm going to put them back. Now, a common problem in Java programming is to name these arguments identically as the fields of the class. So for example, if I have username being used as the name of the field and the name of the argument to the constructor, notice that the code becomes redundant. So we have string username and we have username equals username, but we aren't referring to the actual username field of the person class. In order to differentiate between an argument and the class's field, we use an identifier called this, which is a keyword in Java. So when you say this .username, you're actually referring to the username field of the person instance that is being constructed right now. And this is a common pattern. So I'm going to copy age and I'm going to put it here. And I'm also going to say this .age equals age. And this is a reference to the current person instance which is being constructed. So for example, if I say person Bob equals new person with Bob 24, the this keyword refers to the Bob instance that is being constructed. Earlier, when I said person Alice equals new person with Alice 25, the this instance, the this reference, referred to the Alice instance because Alice and Bob are two different instances of the person class. You get the picture. So this refers to the current instance of the person class which is being constructed. All right, so we've learned about classes, we've learned about instances, and we learned about constructors. And this is pretty tough, and you've learned everything in just about an hour and a half. So people learn this usually after several weeks of programming. And this is pretty concentrated, so I want to congratulate you for keeping up so far. All right, now I want to run the following scenario in your mind. So let's say that in your imaginary social networks in which you have this person class and several person instances, imagine that whenever a person celebrates their birthday, we increment their age by 1 and then make them print something to the console. So let's say it's Alice's birthday. So I'm going to say Alice.age ++ semicolon. So I'm incrementing Alice's age by 1. And then I'm going to say sout. So I'm going to print something. And I'm going to say Alice.username plus. And I'm going to add a space, says, colon, it's my birthday. I just turned. And I'm going to add a space and then a plus, and I'm going to say alice.age. Okay, now this string is quite long, so I'm going to put it below. So plus, and then another plus. I'm going to indent them so that it's easier to see. So Alice's age has incremented by 1, and Alice prints something. Like Alice says, it's my birthday, I just turned, and Alice's age has just become 26. Notice that if I said that it was Bob's birthday, then I would do the exact same thing. I would say bob.age ++, so I'm incrementing Bob's field called age, and I'm basically copying this code. So I'm going to copy it, and I'm going to paste it here. And instead of using Alice's username, I'm going to use Bob's username. So Bob says, it's my birthday, I just turned, and then I'm going to use Bob's age, which is 25 because it was incremented from 24. So notice that we have a lot of repetitive code over here. And this particular code that the computer will execute is basically the same for the two persons. Now, whenever we have the situation where a piece of code is mentally, in our programmers' minds, associated to the person concept, that is called a method, in the same style as a piece of information is called a field. So I'm going to go back to the person class, and I'm going to define a method called void celebrate birthday. And I'm going to add some parentheses, and I'm going to add a curly brace, and IntelliJ will automatically put a corresponding closing brace. Void is a very interesting keyword, and we are going to discuss it shortly, much like public. So these two, I promised I would discuss what they mean. So celebrate birthday is called a method because I can extract this particular piece of code, which was identical for Alice and Bob, and make it general for any person class to celebrate their birthday. So I'm going to paste it here. And instead of Bob, so I'm going to indent this code. Instead of Bob, I can use this, because this is the reference to the current instance. All right, so whichever person calls the celebrate birthday method will refer to this instance. So if I said, instead of writing this whole code, if I said Alice dot celebrate birthday, then this particular structure over here will make the computer invoke or execute the code that the celebrate birthday has defined in the person class. So whenever I say Alice.celebrate birthday, the computer will know what celebrate birthday. Well, it's a method, and the computer will then jump to execute the code that this method contains. And so Alice's age will increment, and Alice will print out, Alice says, it's my birthday, I just turned 26. In the exact same fashion, I can reduce this code, which is identical, to say Bob.celebrate birthday, which runs the exact same thing. So when I say Bob.celebrate birthday, the computer will know to jump to the celebrate method in the Bob instance. And so Bob's age will increment, and Bob will print, Bob says, it's my birthday, I just turned 25. So a method are pieces of code attached to a single type. In much the same way as a field was a piece of information attached to a single type, a method is a piece of code that is attached to a single type. So when you call a method on a person instance, then the computer will jump to the code that this method contains, and it will execute whatever this method has defined. Now, I wrote a lot of code, but I haven't tested my application in quite a while. So if I run this application, notice that the compiler will compiler code, and it will print the numbers as discussed in the while, do while, and for loops. And notice what the computer will execute. So system out print line, Alice says to Bob, happy birthday for turning 24. So this is the old system out print line, but watch the last two printed lines. So Alice says, it's my birthday, I just turned 26, because Alice.celebrate birthday does that. So Alice's age increased, and Alice printed to the console, Alice says, is my birthday, I just turned 26. And the same for Bob. So when you say Bob.celebrate birthday, we get Bob says, it's my birthday, I just turned 25. So notice how the this reference changes depending on which instance called that particular method. Good. Now, in a class, we can have as many methods as we like in the same style as we can have as many fields as we like. Now, I promised I would describe and I would explain what this void keyword does. A method has the capacity to execute code. So when you call a method, when you invoke it in the style that we did earlier with Alice.celebrate birthday, we instruct the computer to jump to this code and run it. All right. So a method is able to make the computer jump to this particular code and execute it line by line. But a method also has the capacity to return values. Now, I will describe what this void keyword does by comparing it to something else other than void. So let me assume that this person class has a method that returns a value of type string, and I will name this method throw party, and I will open some parentheses. And much like a constructor, we can pass arguments to this method. So I'm going to pass two arguments, for example, int number of people, comma, and a string, let's call this favorite place. And I'm going to open and close some curly braces as well. So this method will take some arguments, and it will return a value of type string. Let me describe how this thing works by implementing this method. So let me assume that this third party returns. So I'm going to use the return keyword, and I'm going to say this.username plus space says. And I'm going to put in a quote. I'm going to throw a party at, and now I'm going to add a space, and then I'm going to add another plus, and I'm going to insert the favorite place, and then another plus, and I'm going to add a string, and I'm going to invite plus n people plus the string space people, exclamation mark, and then semicolon. Now, this is particularly hard to understand at the very beginning. So I'm going to use this method at the very top. So I'm going to say string, let's call this Alice's party. So I'm going to define a variable of type string that I named Alice's party. And on the right hand side, I'm going to say Alice dot throw party with some arguments. Let's say Alice invites 20 people to the favorite place, my house, semicolon. What have I done here? So when you say Alice dot throw party with the number 20 and my house, the computer will then invoke this method, and so it will run this expression. It will evaluate this expression to a value by replacing n people with the actual argument 20 and favorite place to the string my house. So when you write alice.throwParty with 20 and my house, the computer will evaluate the super complicated string. Alice says, I'm going to throw a party at my house, because favorite place is my house, and I'm going to invite 20 people, exclamation mark. And this whole complex string will be returned by this method, and it will be able to be attributed to a value, and this variable is called Alice's party. And so if I do sout, system out println Alice's party, then I will obtain this whole complicated string. So if I run this application, notice that we have here in the console, Alice says, I'm going to throw a party at my house and I'm going to invite 20 people, exclamation mark. So a method is a way for the computer to jump to whatever code that method contains, and at the very end of the method, you will add a return statement and you will return a single value. And that single value will be able to be attributed to a variable that I used at the top. Now, the general structure of a method looks something like this. So I'm going to detail it in a multi-line comment below. So a method will need to have a return type. In our case, we have string, and then method name, we have throw party, and then inside parentheses we have arguments in the form of argument type, argument name, comma, and then you can chain it multiple arguments if you like. And then inside curly braces, you can have any code, absolutely any code at all, and at the very end, you need to return a single value. So don't be fooled by this method's only return statement. You can have composite strings. So I'm going to define, for example, a string, let's call this throw a party as, and I'm going to copy this string, this.username plus says I'm going to throw a party at my favorite place. And so I'm going to add some selection here. So I'm going to cut it, and I'm going to attribute that to the string that I called throw a party. So I've defined a local variable to this code. I'm going to define another variable of type string, let's call this invite people, as I'm going to invite n people. So I'm going to cut it, and then I'm going to paste it here and use the appropriate quotes so that the code can compile. Let me put a semicolon at the end so that the compiler is happy with me. And at the very end, I'm going to return a single value. I'm going to return the string composed by the string throw a party plus and plus invite people. So I'm going to say throw a party plus and in between spaces, plus invite people, semicolon. So the return statement always needs to have a semicolon at the very end. And before the return statement, you can write any code you like. All right, so you can use if statements, you can use while loops, you can use for loops, and so on and so forth. You can write any code before the return statement, and the return statement needs to return a single value of any type you like. You can return strings, you can return ints, you can return any type you like, and that particular value needs to be of the same type that you declared at the very beginning. So this particular value is of type string because I declared it right here. Now, the return type is a string in the case of the third-party method, but in the celebrate birthday method, we don't have a return statement because the return type is void. And this is the time where I explain what void means. Void means no return type. So notice we have no return statement, and so this method doesn't return any value at all. And these methods that don't return anything are called void. So I know this is a lot to take in at this moment with these two methods. So these are particularly hard. So if you need, you can pause the video and you can rewind to follow the logical need for this kind of structures. All right. These are pretty hard, especially if you've never coded before. All right. I totally understand it. And if you have any questions, just let me know in the comments. All right. Good. So we've defined methods and we've understood that when an instance of a class calls a method, it might return a value that we can attribute to a variable, or it might not return anything at all, just simply make the computer jump and execute this particular code that the method contains. So this is the purpose of methods. All right, now let me go back to my main application. Because we have created a reference type, we can add methods, and all reference methods may have methods. So all reference types, that is classes, can have methods. And for example, the string type, which is a reference type, as I mentioned earlier, has methods itself. So let me define a string variable. Let's call this a test string to have the value I love Java. I hope you do after this tutorial. And I'm going to call some methods on the string class, which are very useful. Let me print to the console a test string dot, and notice that when you hit dot, IntelliJ will automatically open a small pop-up that describe all the methods that the string class has. And I'm going to invoke the method called length. The method called length returns an int, a number, and this will be the length of the string in the number of characters. So the length method describes the number of characters. Let me show you another method. I'm going to say a test string dot starts with. So when you write start, notice that IntelliJ will automatically narrow down the potential method or field names to match what you've already written. This is called auto completion. And when you double click, you will notice that IntelliJ will automatically complete the rest of this method for you. And let's say, for example, that we want to test whether this string starts with another string that I have here, I love, for example. So starts with takes an argument of type string and returns a truth value, a boolean, whether the string in question starts with the string argument. In our case, I love Java starts with the string I love. All right, so this will be true. I'm also going to show you a final method, a test string dot substring. And notice that we have substring with a bunch of various arguments. We have two methods that are called substring. And this is called method overloading, and it allows you to name multiple methods with the same name, but with different argument types and argument numbers. So we are going to use the begin index and the end index, the two different arguments. So I'm going to use the values 2 and 7. And this returns another string, which is the section of the string between the indices 2 and 7. So the way the characters are counted or indexed in a string are, this is the character 0, this is character number 1, this is character number 2, character number 3, character number 4, character number 5, character number 6, character number 7. So if you do test string.substring between the first index number 2, the first index number 2 is the third character because character indices start with 0. So we are going to run 2, 3, 4, 5, 6. And the character with index 7 is not counted. And so a test string.substring with 2 and 7 will return the string love with a space. All right. So notice that the string class has various very useful methods to process your information. For example, to compute the length of a string, to test whether a string starts with some other string, and whether you can extract a piece of a string. And various classes in Java written by very smart people also have various useful methods. And as a programmer, it is your job to provide your own classes with useful methods for other people to use. All right, so if I try to run the application as we have it so far, we will have the last 3 lines printed to the console to contain the number of characters in the string I love Java, whether this string starts with I love, which will be true, and the substring between the indices 2 and 7, which will be the word love with a space. So if I try to run this application, the compiler will run really fast, and notice that the last 3 lines will be the number 12, the number of characters in the string, the value true, because the test string starts with the string I love, and the final line of the console will be the string love with a space. And I've intentionally put my cursor over here to illustrate the fact that this space is also present here, although it's not visible in the console. All right, so we've learned about reference type. We have created our first class with a constructor, with some fields, and with some methods. This is pretty awesome. So in general computer science, if you wanted to learn all these concepts, you would have needed to take quite a number of classes in initial programming to be able to write this kind of stuff. So I really appreciate that you're following along so far. All right, now let me show you another thing. I'm going to show you arrays. So assume that in your imaginary social network, you have lots and lots and lots of person instances like Alice, Bob, and a million other person instances, and they are all celebrating their birthday today. All right. Statistically, if you have like 1 billion users, you are bound to have quite a number of people celebrating their birthday in any given day. So assume you have Alice, Bob, and let's assume we have, for example, person Charlie as new person with the name Charlie, and let's say 34 or something like that, semicolon, obviously. And you have 1 million other people. And we want to celebrate every single instance's birthday. So we want to call the celebrate birthday method on Alice, Bob, Charlie, and every single instance that we also have in our social network, which are celebrating their birthday. So how would we do that? Well, we would simply say alice.celebrateBirthday, and then bob.celebrateBirthday, and then charlie.celebrateBirthday, and 1 million other user.celebrateBirthday. So let me write this. All right, so if we have 1 million users, you would need to write celebrate birthday on every single one of those instances. Now, for obvious reasons, this is not really practical in the exact same style as counting to 1 million is not really practical by writing count plus plus or counter plus plus 1 million times. And so we need to have some sort of repetitive action that we can run on a set of person instances. And this is where arrays come into play. So I'm going to remove these 3 lines, and instead I'm going to define an array object. So I'm going to say person, and then I'm going to use open and closed square brackets. This is a person array. This is a data structure that can contain multiple persons. And I'm going to name this array, let's call this people celebrating today, to have the value of new person with square brackets, and inside the square bracket I'm going to put a number. For example, I'm going to put 3 persons because I only have 3 people here in my code. But if you have 1 million people, you can instantiate that with 1 million instead. So you can give any dimension of this array that you like. In my case, I'm going to use 3. So when you write something like that, you instruct the computer to allocate enough memory for 3 person references. Inside this array, we can actually make the reference to Alice, Bob, and Charlie by saying people celebrating today at index 0, that is the first person in the array, to be Alice, semicolon. People celebrating today at index 1, that is the second person, to be Bob. And people celebrating today at index 2, this is the third person and the final person in the array, to be Charlie. So this is how we can insert a person reference in an array which contains spaces for multiple person references. So we have 3 spaces which we can fill by identifying people celebrating today at a given index to be a person instance. All right, so we filled this array with Alice, Bob, and Charlie. Now, if you want to go through this array and celebrate each person's birthday, you don't need to call Alice.celebrateBirthday, Bob celebrate birthday, and Charlie celebrate birthday. You can run a repetitive action to go through this array regardless of what instances you have in this array. So I'm going to run as follows. I'm going to define an int, let's call this person index, to start at 0. So I'm going to set this to 0, and I'm going to run a while loop. So I'm going to say while that person index is less than or equal to 2, which is the last index in this array, I'm going to access people celebrating today at that given index, and I'm going to call its celebrate birthday method. So I'm going to run a while loop. So I'm going to say person index less than or equal to 2, or you can say strict less than 3. And I'm going to open and close some curly braces. And inside, I'm going to say person, current person, to be people celebrating today. So you can simply write P, and IntelliJ IDEA will offer you some options to autocomplete. So you can double click this and it will autocomplete the variable number. People celebrating today at the given index person index. So person index starts at 0, and because this condition holds true, the computer will start executing these instructions. And so the current person, which I've defined locally inside the block of the while loop, I've defined the current person to be people celebrating today accessed at index, in my case, 0 at the beginning. And so this will be the same person instance as Alice. All right, so current person is now Alice. Now I'm going to call current person dot celebrate birthday, and so Alice's celebrate birthday method will be called, and at the very end I'm going to increment person index. So I'm going to say person index plus plus. So what have I done here? I've started person index with the number 0, and because the condition holds true, I'm accessing the current person as the array at the index 0. So this will be the same instance as Alice. After that, I'm calling celebrate birthday method on that person instance, in my case Alice, and then I'm incrementing person index, and so person index now becomes 1. Because the condition still holds true, the while loop will repeat again, and the current person will be accessing people celebrating today at person index now 1. And so this expression now evaluates to people celebrating today at index 1, which was Bob, because that's how I set it. And after that, current person.celebrate birthday will call the celebrate birthday method on the new current person instance, which is Bob in this case. After that, we increment person index, which now becomes 2. Because this condition still holds true, we're accessing the current person at index 2 this time around, which is the same instance as Charlie. And now current person.celebrate birthday will actually, in fact, call Charlie's celebrate birthday. And so Alice, Bob, and Charlie have celebrated their birthday. And after that, person index becomes 3, and this condition does not hold true anymore, and the computer will skip this loop. And so if I run this application now, we will see that the last 3 lines in the console will be Alice says it's my birthday, I just turned 27. Bob says it's my birthday, I just turned 26. And Charlie says it's my birthday, I just turned 25. So Alice, Bob, and Charlie all celebrated their birthday in this while loop. Now, why is this while loop interesting? Well, it's interesting because you don't have to copy and paste Alice.celebrate birthday, Bob celebrate birthday, and Charlie celebrate birthday. You can just run a while loop on an array and run each person's celebrate birthday no matter how many persons you have in an array. So if you have 3 persons or if you have 1,000,000 persons in this array, this while loop will stay the same, obviously by changing 3 to 1,000,000 and then leave the rest of the code intact. So this repetitive loop will instruct the computer to automatically call celebrate birthday on every single person instance that you have stored in your array. This is very, very interesting. So we can repeat over an array by starting with an integer, which is the index at which we can access a person instance, and constantly incrementing the person index after we're done with our current person instance. We can also rephrase that. We can rephrase this while loop into a for loop. So we can say same thing with a for loop. We can say for, and remember, for takes 3 elements inside the parentheses. So we have the starting instruction, and our starting instruction needs to be person index equals 0. So person index equals 0, semicolon. And then we have the continuation condition, which is the same condition as the while loop. So person index less than 3. And after that, the third element inside parentheses is the instruction to execute after the contents. And in our case, we have person index plus plus, which is exactly the thing that we wrote inside the while loop. I'm going to open some curly braces, and inside I'm going to put in the contents. And what are my contents? First, I need to identify the current person, and then I will need to call that person's birthday. So I can simply copy these 2 lines, and then I'm going to paste them here. So these are the contents of the for loop. So I'm starting with the person index 0, and as long as person index is less than 3, do this. And after we're doing this at every iteration, at every repetition, we are incrementing person index. So this for structure here is identical. It's equivalent to the while structure that we wrote above. And sure enough, if I run this application, we are going to see the exact same thing. So Alice says, it's my birthday, I just turned 27. Bob says, it's my birthday, I just turned 26, and so on and so forth. So every single person celebrated their birthday, and then the 3 persons celebrated their birthday again, and obviously their age increased as well. All right, so this is what we can do with a while loop or with a for loop. Now, when you want to iterate through an array, you can either do it like this with an index, or you can do it with a for each loop, which I'm going to show you right now. So I'm going to say for, and inside parentheses, I'm going to say person, let's call this P or person, colon, people celebrating today, and then I'm going to open and close the curly braces. Now, this structure means for every person that we call person with a lowercase p in this array, we can do whatever we want inside these curly braces. So I can say person dot celebrate birthday. So this is much simpler and it's much easier to read. So we're basically able to read for every person in this array, call its celebrate birthday method, which I think is much more understandable. And sure enough, if I run this application again, we will see Alice, Bob, and Charlie celebrating their birthday over and over again. All right, so the benefit of this for each loop over here is that it stays the same no matter how many elements you have in your array. Notice that in the while and in the for loop, you would need to adjust the person index limit from 3 to whatever number you have, like 1,000,000, if you have a different number of elements in your array. But with the for each loop, it doesn't need to care. You can have 3 people or you can have 1,000,000 people. This for each loop stays exactly the same. All right, so yet another thing that you learned in the past couple of minutes. So you learned about arrays, which are data structures that can contain multiple references to the same type. So when you say new person with 3 elements, this allocates space for 3 person references. All right, and you also learned how to iterate through an array with a while loop, with a for loop, and with a very fancy for each loop. All right, this is awesome. Let me show you something else. I want to show you static members and methods. Now, static is a keyword in Java, and it's a modifier to mark the fact that a field or a method does not belong to a given instance. Let me give an example. So let's assume that the person class has a string username and an int age, and these fields are proprietary to every single instance of the person class. So every new instance of the person class has a different username and a different age. However, we can also think that a person class itself, by definition, as a concept, has a field or a method that doesn't change. For example, I can say static boolean can fly equals false. And this can fly field over here is false for every single person in existence. This is what static means. So when you say static and then you define a variable and give it a value, that value is applicable to all instances of the person class. So when you say, for example, people can fly, so boolean people can fly, to take the value person dot can fly, semicolon, this can fly is a member of the person class. It's not a member of any person instance, although you can also say alice.canFly, but this can fly field is applicable for any instance of the person class. So we refer to it as person.canFly because it's applicable to the entire person class, meaning that all persons cannot fly. I hope this makes sense. This is true for both members, like fields as we wrote them here, and it's also applicable for methods as well. Let me define a public method down below. So I'm going to, for example, let's call this static string. Static string. Let's call this method get favorite programming language with no arguments. And in this way, I've defined a method that returns a string. Its method name is getFavoriteProgrammingLanguage. It doesn't take any arguments, but it's static. It's applicable to all instances of the person class, and this method will do exactly the same thing. So I'm going to return a string value, for example, the string Java. Now, because I've made this method static, I cannot refer to, for example, username and age because they are different for every person instance. I can only refer to static fields because they are the same to all person instances. And so I cannot return Java plus username, for example, because as I mentioned earlier, username is different for every person instance. However, I can use canFly because canFly is the same for every person instance. So when you define a method that is static, you can only use static references inside the person class. All right, so be aware of this method. And we can also use the static method in the same calling fashion as we used person.canFly by saying, let's call this string, let's call this people's programming language as person.getFavoriteProgrammingLanguage. And because this method returns a value, it can be attributed to a string variable. And the value of people's programming language will be Java. So if I do sout people's programming language, I can see in the console, if I run this application, I will see the string Java at the very end. Good, so you also learned about static members and methods. The final thing that I want to show you before we move on to our little chatbot is access modifiers. Now, in Java, we write a lot of code in real life, so it's a good idea to organize our code and try to think about as little code as possible. And methods help a great deal because when you call a method, when you say person.celebrateBirthday, you don't need to care about how that method is being implemented, about what code this method contains. You can read this code and immediately understand what it does. Now, for similar organizational reasons, it might make sense to have certain fields and methods in our classes be hidden or private. So let's define, for example, a string field inside the person class that I'm going to call secret. And I'm going to give it a value of, for example, nobody needs to know this. Obviously with a semicolon at the end. But with a twist, I'm going to make this hidden or private. So if you want to hide a field from outside code, you mark it with a keyword private before the declaration of that field. And so if I want to print, so I'm going to say sout, and inside I want to say alice.secret, this will be a compiler error because secret is not accessible from outside code outside of the person class. And if you hover over the red secret word, you notice that IntelliJ is smart enough to give you an informative error. Secret has private access in the person class, and so you cannot use it outside of the person class, but you can use it inside of the person class. So I'm going to remove this line. Private is a keyword to be called an access modifier. So private is an access modifier. Other access modifiers include the keyword public, which allows any outside code to access this field or method, or in our case, constructor. All right, so this is why I've marked this constructor public so that any other outside code can access this constructor. And you can also have the keyword protected, which is more complicated, and it allows a field, a method, or a constructor to be accessed from a certain class and all of its child classes. And inheritance is a more complicated Java topic that I'm probably going to talk about another time. So don't stress yourself with protected. And there is another access modifier, which is no modifier. So when you write a method or a field or a constructor that doesn't have an access modifier like private or public, implicitly it has a no modifier, which means that this method or field can be accessed inside the same package. And a package just means the same folder. So if you write some more code or if you define some more classes inside the same com.rockthejvm package, you can access these methods. If you define some other package outside of com.rockthejvm, you will not be able to access these methods. So implicitly, the no modifier, the default modifier, is called package protected because it allows a method or field to be accessed inside the same package. All right, so I'm gonna write this here. All right, so you've learned about access modifiers as well. Now, I'm going to hit the line back with the sout alice.secret, and I'm going to comment it out because it's still important, but I want to not impede the compilation of the code. So this will be a compiler error because secret is private. All right. Good. So we've learned about the static modifier, which means that a field is the same, or a method runs the same for every instance of a class. And we've learned about access modifiers. It's time to go back all the way to the top and explain what public class main and public static void main does. So any Java application needs to have at least one public class, so accessible from any other piece of code. So you need to have at least a public class, and that public class must have a method called main, exactly spelled like this with lowercase letters, that is both public, static, and returns nothing, so it returns void. Now you understand what each of these orange keywords does. So public because this method is accessible, static because you don't need to instantiate the main method to access this method, and this main method must have a single argument of type string array. So this is a general operating system reason for which a Java application must have an arguments array of type string. But this is exactly the method signature that your application needs to have. So a method signature is the combination of access modifier plus static or non-static, I'm going to put this in parentheses because it's optional, plus return type, plus the method name, plus the list of arguments. So the combination of access modifier, static or no static, return type, method name, and the argument list is called the method signature. And you want for your Java application to have at least a public class. The name of the class doesn't really matter, but it must have a method with this exact signature: public, static, void, main, with the arguments as a list of string. If you change any one of these parameters, if you change the access modifier, you will not be able to run this application. So if you right click, you won't have the run option here in this menu. Or if you change the static modifier, again, you will not have this option. Or if you change the return type to string, for example, again, no option to run it. Or if you change the name of the method from main to main method, same thing. Or if you change the argument list from string array to, for example, int array, again, it's grayed out, it won't be able to run. The name of the argument doesn't really matter. So if you change from args to arguments, this still runs. The name of the argument doesn't really matter. But you must have public, static, void, main with an argument of type string array in order for your application to run correctly. All right, so you've learned a ton. You've probably learned more than other people learn in days or weeks. All right, so I'm really grateful that you followed along so far. This is where the actual lesson will end, but it's time for us to move on to make our little chatbot with whatever we've learned in this tutorial. So I'm going to open my file explorer, and under com.rockthejvm, I'm going to create another class. So I'm going to right click on the com.rockthejvm package. I'm going to say new Java class, and I'm going to name this chatbot. I'm going to leave it as a class. I'm going to hit OK. And notice IntelliJ has automatically created a class definition for us with the package definition com.rockthejvm. This is automatically filled up for you. And the class is public, meaning that it can be accessed from any other piece of code. And in order for us to make this chatbot runnable, we will also need to have a main method as we did before. So we are going to say public, static, void, main with all lowercase letters with a string array arguments. and open and close some curly braces. And once you do that, if you right click on this code, you will have the option to run the chatbot application. Of course, it doesn't really do anything because the main method doesn't have any code, and it's our job to fill it up. So we will make this application be very simple. We are going to make this chatbot ask for our name, and we are going to type it in the console, and this chatbot will try to guess our age by answering a few questions in the console as well. And then we will make this chatbot count to any given number we write in the console. So I'm going to teach you one last trick besides everything that we've learned so far in the other application. I'm going to teach you how to use an existing class from the various utility Java packages. And we are going to use a scanner to read data from the console that we type ourselves. So I'm going to use a scanner. And when you type in scanner, notice that IntelliJ offers you a bunch of options to import, and I'm going to double click on the first one from Java util. So I'm going to double click it, and notice that IntelliJ has automatically added a piece of text at the top of the file to import Java util scanner. When you import a class, you will make it accessible to your own code. So scanner is now available in our code, so we can use the scanner type as a class. So I'm going to say scanner, I'm going to name this scanner with a lowercase s, and I'm going to create a new scanner. So I'm invoking the scanner's constructor, and as arguments to the constructor, the scanner needs an input stream, and we are going to type in system.in. Now, when you say system.in, system is also a class, and when you say system.in, in is a static field. This will be the value that we pass to the scanner object's constructor, all right? So we have instantiated a scanner object, right? Much like we did for our person class. Now, I'm going to print something to the console to be really interactive, and then it will allow us to type something to the console ourselves. So I'm going to do sout, so I'm going to print line, and I'm going to say, hi, I'm Rock, the chatbot you programmed. May I know your name? So I'm going to print out again. So I'm going to copy this line, and I'm going to say, may I know your name? Question mark. And now it's our turn to type something into the console. And we will obtain the line, the string that we type into the console by defining a string variable, let's call this name, as scanner dot next line. So when you call the next line method, the scanner will fetch the string that you type from the console, and because you call a method, it returns a string value which can attribute to the name variable. After we obtain the name variable, then let's assume that our Rock chatbot will greet us politely. So I'm going to do sout, and I'm going to print nice to meet you, comma, and I'm going to put a space, and I'm going to concatenate the name string that I obtained from the console. And we concatenate strings, you guessed it, by using the plus operator. So I'm going to use it, name. And then I'm going to add another string with a exclamation mark. So nice to meet you, Daniel, for example, if I type in Daniel to the console. So let me go ahead and run this application and see how it runs so far. So I'm going to right click and run this. Good. So we have in the console, hi, I'm Rock, the chatbot you programmed. May I know your name? And notice that the application has paused and waiting for me to type something into the console. It hasn't stopped yet. So I'm going to say Daniel, and then I'm going to hit enter. So now the chatbot says, nice to meet you, Daniel. All right, so our chatbot is able to fetch our name from the console. Let's do another more advanced functionality of this chatbot, and we will make our chatbot that we named Rock to guess our age from some information that we supply into the console. And we will guess our age by uniquely identifying the only number less than 120, which has a specific set of remainders when you divide your age by 5, 7, and 9. So we will supply 3 numbers into the console. Remainder of age divided by 5. So that is age mod 5. We will supply age mod 7. And we will supply age mod 9. So we will supply 3 numbers that signify age mod 5, age mod 7, and age mod 9. Because I'm 28 years old, age mod 5 will be 3, age mod 7 will be 0, and age mod 9 will be 1. And we will make the chatbot infer or automatically compute my age based on either a mathematical formula, if you already know how to do it, or in our case, we will simply iterate through all the possible numbers and we will identify the only number that has the numbers 3, 0, 1 when it's being divided by 5, 7, and 9 respectively. So I'm going to print something to the console to make our chatbot interactive. So I'm going to say sout. So I'm going to write as follows. I'm going to try to guess your age. Then I'm going to write another line to the console. May I know the remainder of your age divided by 5? I'm going to write as follows. May I know the remainder of your age divided by 5? Question mark. And at this point, the application will pause and it will wait for me to input a number. And in much the same style as we read a line from the console, we can automatically parse a number from the console. And I'm going to define a variable and I'm going to name this age mod 5 as scanner dot, and I'm going to use next int. So if you say dot, IntelliJ will pop up a small dialog with all the possible methods that you can use that return an int. And we are going to use next int to automatically fetch a number from the console. And this number will be attributed to age mod 5. Good. Now, let me do a very similar thing. So I'm going to copy these 2 lines. And I'm going to print out thank you. May I know the remainder of your age divided by 7 this time around. And I'm going to, again, scan an integer from the console, and I'm going to name this age mod 7 this time around. And I'm going to copy these 2 lines once more. And I'm going to print out thank you. May I know the remainder of your age divided by 9 this time around. And I'm going to name this variable age mod 9. Now, I named these variables age mod 5, age mod 7, and age mod 9. You can name this however you want. You can name this ABC if you so like. All right? Good. So we are scanning 3 different integers from the console. Let's print them out just to be able to test that our application runs correctly. So I'm going to print out you wrote, and then I'm going to put in age mod 5. Then I'm going to put a comma. Then I'm going to add age mod 7, and then I'm going to add another string and with a space, and then I'm going to concatenate age mod 9, just to be able to test whether I've inputted the right 3 numbers. So let me go ahead and run this application to make sure it runs correctly. So hi, I'm Rock, the chatbot you programmed. May I know your name? Yes, it's Daniel. I'm going to hit enter. Nice to meet you, Daniel. I'm going to try to guess your age. May I know the remainder of your age divided by 5? 28 divided by 5 is 5 and mod 3. Thank you. May I know the remainder of your age divided by 7? It's 0. And may I know the remainder of your age divided by 9? It's 1. Good. So you wrote 3, 0, and 1. The application was able to run or read the numbers that I inputted in the console. So I'm going to remove this line and carry on. Good, so we can read age mod 5, age mod 7, and age mod 9. Now it's time to automatically infer our age. Now, there is a mathematical formula that will combine these three numbers and automatically deduce an age. However, we are going to use a brute force approach. We will make the computer scan through all the possible numbers, and the first number that gives age mod 5, age mod 7, and age mod 9 exactly as we wrote in the console, we will attribute that to the age of the user. So I'm going to define a variable, int age, to be 0. And I'm going to also define another variable called potential age to be 1. So I'm going to use this potential age as some sort of a counter, much like we did earlier with the while loop. So I'm going to iterate with potential age. I'm going to increase it one by one, and I'm going to test whether the potential age has these three properties. Potential age mod 5 is the first number, potential age mod 7 is the second number, and potential age mod 9 is the third number. So I'm going to use a while loop. So I'm going to say while, and I'm going to stop at potential age less than or equal to 120. This is the oldest living human. So 120 is a reasonable limit for a human age in 2020 as I'm recording this. If you're watching this tutorial 100 years from now, the limit might change, so change it as you see fit. Good. Now I'm going to run as follows. If the potential age mod 5, so remember the mod operator tries to divide this number by 5 and it will keep its remainder. So if potential age mod 5 is equal, so double equals age mod 5, and potential age mod 7 is equal to age mod 7, where's my cursor? Age mod 7. I'm going to put this on a separate line so that it's easier for us to read. Okay, so with extra tabs. And then I'm going to and potential age mod 9 equals age mod 9. And then I'm going to open and close some curly braces. And if this condition is true, then age is equal to potential age. So I'm going to run through all the numbers from 1 to 120, and the first number which has these three properties, potential age mod 5 must be equal to the first number, potential age mod 7 is equal to the second number, and potential age mod 9 is equal to the third number, then this age, the real age of the user, is equal to this number that I've tried. All right, then I'm going to increase potential age. So I'm going to say potential age plus plus. So notice we're using quite a complex structure here. We're using a while loop. The condition is potential age less than or equal to 120. The if condition has a composite boolean condition, boolean truth value, and the truth value is obtained by comparing potential age mod 5 with age mod 5 with a double equal sign. So be very careful how you write the double equal sign. This is not the same as having a single equal sign. So potential age mod 5 must be equal to age mod 5, and potential age mod 7 must be equal, and potential age mod 9 must be equal to the third number. And if so, if all of these conditions are true, then I'm storing age to be potential age. So the value of age becomes the value of potential age, and at the very end we are simply increasing potential age. And while we are iterating for potential age all the way from 1 to 120, there is a single number that has these three properties all together. So age will be the real age of the user. Good. At the very end, after we've identified what the age is, let me print that out. So I'm going to say sout, and I'm going to write I've deduced that your age is, and then I'm going to put in a plus, and I'm going to put in an age. All right, the same age that we computed here with this small algorithm. So let me run the application and see how it fares. So hi, I'm Rock. May I know your name? Yes, it's Daniel. May I know the remainder of your age divided by 5? You can put in any number you like, which is applicable to your own age. So I'm going to use 3, 0, and 1. and I've deduced that your age is 28. So the chatbot correctly identified my real age as 28. If you put in your own numbers, the chatbot will identify your own age as well. So the bot works correctly, that is, if we input the correct data. But if we don't input correct data, this bot can easily be fooled. So if I run this application and my name is Daniel and your age divided by 5 is, I don't know, 45 or something like that, and some weird numbers, then the bot will say that I've deduced that your age is 0, which is incorrect. So if we have the bot deduce that our age is 0, we need to show some kind of error message that the bot was unable to find out our real age, most likely because the data that we inputted in the console was incorrect. So we need to test that. So we're going to say if, and I'm going to open some simple parentheses. If age is still equal to 0, all right, so this is the comparison condition. So if age is equal to 0, then I'm going to print out something like error. I couldn't identify your age. Most likely, your numbers are incorrect. Okay? Otherwise, so else, I'm going to open and close some curly braces, and we are going to put in the I've deduced your age line inside the else branch. So let me try to run this application again now. My name is Daniel, and let's put in some fake numbers. And notice that the chatbot correctly identified an error. I couldn't identify your age. Most likely your numbers are incorrect. All right. So we have programmed a chatbot to identify an error with our data. Now, why did I write this piece of code like this, if age equals 0? Well, if at this point age is still equals to 0, then that means the while loop was unsuccessful in changing age to be potential age. In other words, there was no potential age less than or equal to 120, which holds these three properties. And so the age was not really modified from its initial value of 0. So if age still holds its initial value of 0, then that means the potential age could not be successfully computed, and so there is no real age of the user, which is a cause for this error message that we show here in the console. Good, let's continue. I'm going to make this little prompt a little bit more interactive, and I'm going to add another string, and I'm going to say : perfect time to learn Java! ! Good. Now, I'm going to add a final feature of this chatbot, and after this tutorial, you can enhance this chatbot in any way you like. I'm going to print out the following string. I can count really fast. Wanna see? Give me a number. Colon. And at this point, the application will pause and it will ask for a number, and we will read that number in the same style as we did earlier with the age variable. So I'm going to add another variable. I'm going to call this limit, and I'm going to use the exact same scanner.nextInt to read this value from the console. After that, after we have this limit variable, we will make the chatbot print out all the numbers from 1 to limit. So we are going to use a loop, either a while loop, but here I'm going to use a for loop just to get this into your muscle memory. If you remember, the for structure has 3 instructions inside these parentheses. The first instruction is the initial instruction, and here we will define an int counter equals 1. So notice that we can also define variables inside the initial instruction. So int counter equals 1. The continuation instruction would be to say counter less than or equal to the limit that we obtained from the console, semicolon. And the thing that we do after the contents have been executed, we will say counter plus plus. We will increase the counter by 1. And after the parentheses, obviously, I'm going to open and close some curly braces, and I'm going to print out the counter. All right, so I'm going to print number 1. Is the counter less than limit? If so, then I'm going to increase counter plus plus, and so on and so forth. This loop will print all the numbers between 1 and limit inclusively. And after the end, I'm going to s out, that is print line. I'm going to print in the following string, done. See how fast I was. Going to end the chat now. Have fun. All right, and at the end, we are going to simply stop the application because we have no more code. So at this point, our chatbot is complete. So we can simply right-click and run it. And it will ask for our name, Daniel. Nice to meet you, Daniel. I'm going to try to guess your age. May I know the remainder of your age divided by 5? Let's assume that my age is 47 this time. So the age divided by 5 is 2. The age divided by 7 is, I think it's 5, because 47 divided by 7 is 6 mod 5. And may I know the remainder of your age divided by 9? 47 divided by 9 is 5 mod 2. All right, so I've deduced that your age is 47. Perfect time to learn Java. I can count really fast. Want to see? Give me a number, and you can put in any number that you like. I'm going to put in 451. And if I hit enter, notice that the chatbot automatically printed out all the numbers between 1 and 459 in succession. See how fast I was? Going to end the chat now. Have fun. So this is your first real Java application. Congratulations, I'm really proud. In just 2.5 hours, you were able to create your first standalone Java application. Now, there's one last thing that I want to show you if you want to share this with your friends or with any other people that you want to play this application with. So I'm going to show you how to package this application so you can send it to other people. I want you to go to File and Project Structure, which you can access on a Mac, for example, with Command semicolon. I believe there is an equivalent shortcut on Windows as well. And click on Artifacts here on the left-hand side. And then click on plus, which will pop up this small menu. Hover over jar and hit Modules with Dependencies. So from Modules with Dependencies. A small dialog will pop up, selecting Module Java Tutorial, so leave this as is, and then click on this little folder icon, which will help you browse all your classes in this project. And we will select Chatbot as the main class of this whole application. So double click on this and hit on this small checkbox, copy to the output directory and link via manifest. Don't stress about what this thing means, and hit OK. So now we have our first specification of an artifact that is a standalone application. Hit apply and then OK. Good. Now, you will hit at the very top in the build menu, you will go to build artifacts. So click here, build artifacts, and a small pop-up will build with your Java tutorial jar and hit on build. The compiler should be really fast and compute the jar that you will be able to send to other people from the code that you've written in this tutorial. So now you have, if you open your file explorer, in the out folder you have 2 folders here, artifacts and production. This is the bytecode that the compiler has already generated. So in artifacts, you have this Java tutorial jar that you will be able to send to other machines, to other people to play with. Now, I'm going to test this application by opening a terminal. Because this is a console application, you will need to open it in a terminal. Even if you're on Windows or a Mac or Linux, you should be able to play with this application regardless. So go to View and then Tool Windows and then open a terminal window. So click on Terminal here on the right. This will open a terminal, regardless of whether you're Windows, Mac, or Linux, into the folder of the Java tutorial that you've created at the very beginning of this video. Now, I want you to go cd out. So cd changes the directory to the out folder. Then I want you to cd artifacts, and you can hit AR and then hit a tab and it should autocomplete. Otherwise, just type in artifacts. And then under artifacts, do cd Java tutorial jar. So you can hit Java and then a tab and it should autocomplete. Hit on enter. And then you will hit Java -jar. This is the Java command line application. -jar is a command line argument, and then you will hit java-tutorial.jar. You can hit Java and then hit a tab and it should autocomplete. So java-jar java tutorial.jar will execute this standalone Java application in your terminal. And you can do this in your standalone terminal if you open a terminal window on your computer, if you're on a Mac or Linux or a shell terminal on Windows, you'll be able to do this exact same thing. So you will be able to hit on enter. And if you hit enter, the chatbot will pop up. Hi, I'm Rock, the chatbot you programmed, and this will run exactly the same as we ran in the console. So my name is Daniel. May know the remainder of your age divided by 5, 3, 0, and 1. I can count really fast. Want to see? Give me a number. It automatically inferred my age to be 28. And let's make it count to 14, for example. Notice that the chatbot is really fast to count to 14, and it will print the last line, and the Java application will simply exit and return to my standard terminal. So this jar application that you just built is now applicable to be sent to any other computer that you want. So Macs, Linux, or Windows, as long as they have Java installed on that machine, you can automatically submit that jar and execute it as we did in this terminal. So congratulations, you packaged your first Java application. All right, so you've learned a ton. And in just under 3 hours, you learned more than most people learn in days or weeks. So congratulations. I'm really, really proud of you. And I hope this tutorial was helpful. I'm going to attach a link to everything that we discussed, including on how to make this tutorial work on half of your screen so that you can code on the other half. If you liked or hated this setup, just please let me know in the comments. If you like this setup, I'm going to create more tutorials like this so that it's easy for you to follow along. If you need to download this video or the code that we wrote, check out the links in the description to this video. And in the meantime, if you like this video, go ahead and subscribe for more videos like this, and follow Rock the JVM on Twitter and LinkedIn for updates on upcoming material. Now, once you get some more experience and once you're ready to dive into more advanced stuff, I'll be waiting for you in the Scala trainings that we have here at Rock the JVM. So I hope this video will serve as a good start to your software engineering journey. In the meantime, I'm Daniel, and I'll see you soon. You rock.